Welcome to my project. It's about clustering the iris datasets. I will go through each line of it and give you a quick explanation. First, I imported the modules used in our project, NumPy, Pandas, Matplot library, and Seaborn. And for our clustering, I imported the key means. And for assessing our clustering process, I imported the silhouette scope. Here I loaded the dataset into a data frame called iris data. Then I checked if my data has null values. As we can see here, the number of null values in each column is 0, which is excellent. So now we can go forward. And after that, I printed the columns names in order to get an idea about our parameters. ID is one of our columns, so we can get rid of it as it's not crucial in our data. This will enhance the clustering process and, of course, will make it faster. After that, I printed the type of each column. All of them are of type float, except the species column. So here we did some mapping in order to transform it into a numeric column. And after that, I printed the first 5 rows in our data frame. After that, I shuffled my data. This is to make sure the ordering will not affect the clustering process. The next step included doing clustering for our data set with different number of clusters at each time. My range was from 1 to 15. I calculated the inertia each for each clustering and stored the inertia in order to do some visualization later. And here is a graph for our inertias. I used the elbow method to choose the optimal number of clusters. We can see that our line is getting stable at 3, which means that the optimal number is 3. So our number of clusters will be 3. Then I did the clustering using the k-means model. And after that, I got the labels of our clustering. Then I grabbed the clustering result based on 2 of our 4 parameters, the petal width and sepal length. And I grabbed it again based on the other 2 parameters, the sepal width and the petal length. And finally, to assess our model, I used the silhouette score, which is similar to the evaluation matrix, but used with clustering. The silhouette score for our model is 0.66, which is good. And that's it. Thank you for listening.